Swayam Prabha. Digital India. Educated India.
Welcome friends once again to our NPTEL MOOC module on health economics. This is a 12 credit 12 weeks program, a 4 credit equivalent course. You are exposed to learn various aspects of health economics. In this week we are emphasizing on supply in healthcare and its perspectives or discussions. In this particular lecture, we are targeting to do it the explanation on production and cost of healthcare and how students or the scholars used to follow from different readings. So, what we did in the previous lecture, it was on the physicians and hospitals in healthcare market as the provider of health and healthcare. So, the particular target of this lecture is how economic analysis of production and cost are applied to healthcare, and this will indeed contribute to the efficiency analysis, market failure discussions, economic evaluation and theory of supply and market structure. So, what is all about the production and cost? We will start with the very basic principles of production or the production theory. In the start we wanted to just mention that economic theories of supply can be also extended to healthcare as an economic good. Healthcare comprises an extremely diverse range of goods and services, including screening programs, surgical procedures, pharmaceuticals, counseling services, and we all refer all these to as products. There are many different types of healthcare provider as well, including hospitals, GP practices, pharmaceutical companies and ambulance services. We refer those sub part of healthcare as firm, as like our industry. So, firm we are actually addressing which each category of healthcare, different types of healthcare. The quantity of healthcare product produced by healthcare firm is referred to as its output. So, to define healthcare output as part of healthcare facilities, though is a very tedious task. However, there are to simplify this, there are two approaches followed. One is called change in the level of health and amount of care provided, and usually considered as the intermediate output. Okay. So, how production functions are defined? What does production function do? It exhibits the relationship between inputs that goes into the manufacturing process and generate output, and in this context we are actually identifying specific outputs of healthcare industry. So, what is an input? In this case used to be the factors in production function, and usually they are called labor, land, raw materials and capital. And within an eye hospital, what are inputs in the especially in the context of eye hospital we are mentioning. What are the inputs in the production of cataract removals in a surgical unit? So, it is basically the labor involved for such a surgeon labor hours, then anesthetist and nurses, and there will be capital involved as well, like machineries, hospital bed, health machinery, etc. Instruments are used at the theater, operating theater, and there will be materials also involved for such as drugs, or the medicines, dressings, disposables. Okay, and these all constitute the inputs, and what these inputs produce and what is the output here in this case. Basically, the simple target in this example is a better eye health. And can we measure the eye health perfectly? What if operation is unsuccessful, and in that case what is the output? So one intermediate output is of course the number of operations we did. Generally these are the quantity figures are required when we operate efficiency analysis or to find out efficiency or productivity analysis. So quantity figures are usually required. And we know that there are a number of directions where quantitative estimations are difficult. So we need to go by some qualitative approximations, maybe through developing indexes, maybe taking some proxy variables. Okay. Now that we have studied a production process in healthcare, several questions arises. So like to what extent can different inputs such as surgeons, nurses be substituted for each other? Now actually we are leading the discussion in terms of their input combinations or the substitutions to have a better performance indicator. So if we employ more nurses, how many more operations will be able to perform? How many more operations will be able to perform if we use more of all of the inputs? How can we tell if production is being carried out efficiently? This is what I just mentioned. Hence, the production function, can be presented in an equation like Q as a function of x1, x2, and xn. Q is our output quantity in quantity, and x are inputs. X may be, as I already told you, the labor hours of the surgeon or the nursing staffs, okay, or maybe x2 or another capital use, maybe machines, maybe operating theater itself. Okay. So similarly, other factors may be building is required, beds are required. Finally, output, as I already mentioned that case, we are taking the incidence or the number of cases or treated. Okay. So if you employ one more nurse into process and keeping other inputs constant, the change in total number of operation is actually called marginal product of nurse or input. As we already read that in simple microeconomic theory, you must have read marginal physical productivity of labor, okay, which is simply defined as dq by dl. Okay, and you might have also read mpk with respect to dq by dk. All right. So similar concept we are just using here to clarify. Marginal productivity of the ith inputs is nothing but del q by del x. X is our inputs. So and in an obvious context where the natural laws of production follows the principles of diminishing marginal returns, and however there are different stages of the production process. If you remember, there are first stage, second stage, and third stage in the production function. I am not making you more confused. I think when your L we used to take and Q we used to take here. When L is 0, we used to get 0 as the output. So we used to draw this type of production function, and reaching at a maximum point, Q we used to say Q is a function of L. Okay, and capital we are saying as fixed in the normal production function. If you just remember a microeconomic theory, there are different inflection points as well, that's precisely identifying the changes from one stage to another one. There are some stages which identify the maximum production. We refer to dq by dx equal to 0, and if you remember, we used to draw this type of diagram as well to identify marginal productivity of labor, etc. Okay, and even if you remember, we used to draw the average productivity of labor as well, APL, and accordingly we derive the stages of production. The inflection I have just derived mentioned here. So, inflection point should actually occur in this point, since the maximization reaches here, and somewhere another maximization occurs due to the average productivity. So, another point of inflection can be presented. And the third one is of course here. So, accordingly we derive first phase, second stage and third stage. Stage 1, stage 2 and stage 3. I am just recapping the microeconomic theory. But here somewhere we are actually touching up this concept, and to differentiate how healthcare is little different, and but largely it follows the production function. The diminishing marginal product is the obvious outcome of the production function, because in the first stage we generally do not target to be our objective function, because others, if we just target and try to maximize the first stage, we used to be underutilizing our capacity. So, we need to give the space for capacity extension. We try to reach at the maximum possible point. Hence, the most important effective hours to derive the best combination of labor for the output is nothing but the diminishing phase. Hence, the production function is exhibited in the DMU phase. But in this case DMR, diminishing marginal returns, okay, diminishing marginal returns phase. So, this states that as we keep on increasing the input, there will be change in the output in different proportions, and since it gets declining, get a declining rate in the output after certain time, that is basically follows a law of diminishing marginal returns phase. This is also called diminishing marginal diminishing marginal marginal returns, and diminishing marginal productivity as well, since we are emphasizing on productivity. And in some book you will find diminishing marginal physical productivity, okay, of L, etc. This kind of words you might find. This is precisely the figures taken from the work of World Bank 2009. It is on total health expenditure and output is life expectancy, okay, and the relationship is that health expenditure has diminishing returns. So, just for you to check, and if you remember, we also explain, we used to understand in the simple microeconomic book. Even if you haven't read, still you can easily cover it. Isoquant simply presents the combination of factor input that result the best output. Okay. So, the combination, I mean, it is basically the mapping of the combination of factors that result into the optimum level of output, and or indirectly, once the optimum output is defined, what are the best combinations possible that will result into the same quantity, okay, every time. In this case, we have taken two factors. They are doctors and nurses. For each combination of these inputs, there will be some output or operations performed. Isoquant for different combination of two inputs if output is the same, and that is termed as isoquant. Basically, output is the same. In the isoquant, the output has to be same, and we are trying to define the best combinations, and it is presented here. This curve maps the output for different combination of nurses and doctors, okay, and this is actually called isoquant. ISO stands for equal and Q stands for quantities. All combinations are deriving equal quantities. Okay, so there are possibility of substitutability between these two inputs, and slope at any point on isoquant measures the degree to which different factors of production can be substituted for each other. The slope is basically, if you take a slope anywhere, that is precisely this, let it be, and this slope of isoquant is called marginal rate of technical substitutions. So, MRTS, marginal rate. So, basically from the marginal changes can be delta doctors and here delta nurses. So, here basically it is delta n by delta d. Okay. So, over here delta j is our doctor and j is our nurses and I stands for doctors, and this is precisely for the best combinations to be attended. The change in the technical substitutions must be corresponding with the change in their marginal productivities. So, the marginal productivities has to be equalized. This has to be equalized with the marginal productivity of D with respect to marginal productivity of N. And why we are just making a reverse and used to be the slope used to be negative, and this is also negative, and in that case we used to derive like total productivity like delta D times marginal productivity of D should be equalized with delta N times marginal productivity of N. Okay. Because the change in from one point to another point, the total output remains constant, hence these two sides should be equalized, and hence because this is nothing but the total Q, all right, the Q generated out of the change. So, delta Q, sorry, this is nothing but the delta Q. So, delta Q has to be same. Hence, it is nothing but the ratio. So, ratio is actually simply highlighted in this figure. So, isoquant is convex to the origin, and to the origin we are actually mapping to the origin, and then there are even properties why it is convex. You have to take first order and second order derivative and then understand the changes. MRTS decreases as we move from left to right along with the isoquant. So, the returns to scale of production, we discussed first the basic isoquant, then there are scale returns, scale of returns or returns to scale of production exhibit differently in different stages. We used to read a concept called constant returns to scale, then increasing returns to scale and decreasing returns to scale. So, constant basically follows the property where the production function holds with CRS when a proportional increase in all inputs result in an increase in output by the same proportion. In an example, we have said that 10 times increase in nurses or nurses and doctors as a combination or other inputs will result in 10 times as many as operation performed. That means the output changed by 10 times since we changed the inputs by 10 times. That is basically the answer for CRS. Whereas increasing returns to scale is basically your output increases more than proportionately than that of your change in proportion of your inputs. So, if operations basically our output is Q, if operation increase is by 11%, then that of your input is of 10%, we follow the IRS, increasing returns to scale function. In decrease one, if it is just the reverse. Okay, this is what is explained in this paragraph. I think I have already explained. However, when we see increasing returns, we see increasing returns to scale, we have there are two main factors which account for increasing returns to scale. One is called indivisibility and specialization. So, indivisibility we mean because of its technical and managerial indivisibility. This means that there is a certain minimum size of the factor, and even if it is large in relation to the size of the output, it must be used. Like a body scanner in a rural facility, where there are only a few patients, may not be used to its technically possible capacity. Body scanner, when number of it's lumpy in nature, and usually it is technically indivisible, hence it requires more number of patients to be scanned. But if you are just scanning very few, then its efficiency is not observed. Hence it is the efficiency, the better use and the value derived when, or even the efficacy of it is derived when you actually apply for more patients. Similarly, specialization, when specialization due to division of labor, it is related to divisibility issues. Usually the variable inputs are considered to be highly divisible. However, in the fixed factor, in the long run, they are also considered to be divisible. So, what is the point of explanation in this case is that your factors are otherwise known for their contribution in specific field, and some of the factors are can be allotted or allocated with a specific domain, and they will used to perform very well. Like a small hospital may have to employ general surgeons to deal with many areas of surgery, but a larger one may be able to employ a specialist surgeon instead of just as normal surgeon, who become proficient in performing specific type of surgery and can produce better output, and there might be more consultation because of name and fame. Okay. And constant we have already discussed, but economists believe that if there is less inefficiencies of production, no individuality problem, no specialization issue, then expansion in scale leads to a situation where returns to scale increase in constant returns to scale pattern. And in the DRS case, we already said the output changes are comparatively lesser than that of the change in the inputs. It might be due to your managerial difficulties or due to the problem at the enterprise level. So, managerial, basically when the scale of production expands, the coordination and the control on different factors of production tend to become weak, and therefore output fails to increase in the same proportion as the factors of production increase. In the enterprise context, this region considers enterprise as a whole an individual factor of production. When other factors increase, enterprise becomes relatively scarce and leads to decreasing returns to scale function. We have discussed about its Q or the output, its production function. Now, let us also explain to some extent about what is called cost. Economics measure the value of resources by their cost. If for an input unit cost is P and Q units are used in the production, then the total cost will be of course P times Q. Hence, the total cost is presented with the notation as C will be of course your first inputs cost and its price input, that is x1, and its price, then x2 its respective price, and so on till the nth inputs, and the price already I have mentioned. If there are two inputs, that those are nurses and doctors in our case, then cost will be of course price of Q n nurses, price of each per unit of nurses are hired, and then the doctors are taken their price. Then we can draw the respective cost line, and it is linear. So, we can easily present in a linear diagram, and everywhere on this particular line, this is nothing but the equation which I have just mentioned, and this is actually called iso cost, because in all the points are actually explaining the same level of cost, and the slope of the iso cost line is nothing but the minus Pd by Pn. So, you can find out some clarity, you can just take the first order derivative, because this is nothing but you can just take the tan theta of it. This is P tan theta, which is nothing but P perpendicular times P by Q, So, here it is your P is perpendicular, Q is the horizontal distance, this by this. Okay. So, this area you can find out by taking this distance. If you put it the values in the cost function, and you can easily find out the distance. Okay. And so, the maximum, basically this is the maximum possible quantity of nurses if doctors are 0. If you make it D to be QD to be 0, then the maximum difference can be derived, and so on. Slope can be easily derived. The cost function, which I already said, and some of the important concept we wish to get it for understanding the cost function, that is called average cost. AC, that is total cost divided by number of inputs, and used to be deriving through individual average cost, maybe with respect to variable cost, SCL or SC capital. Okay. And marginal cost, then of course it will be incremental change, then delta to be used. So, you can also follow some of the microeconomics book to answer through some example is to give tables to answer. Here given different cost combinations or cost labels, our purpose is to actually minimize the cost. So, in this case the third one, the uppermost one, is not required to be attended, since our target output can be reached at the respective cost function. The choice of factors that minimize the production cost can be determined by the point on the isoquant, that is the lowest associated iso cost. In that, at that particular point, this slope has to be maintained. The slope of the isoquant has to be equalized with the slope of the isocost line. We have already seen the isocost line, its slope is PD by Pn, that should be equalized with the slope of the isoquant, that is marginal probability of D divided by marginal probability of N. Okay. All right. So, we seek to minimize total cost given a fixed product output. So, our objective function, suppose some mathematical questions you can try. If your objective function is to minimize the cost, then it should be the C function is your objective function. Then C is nothing but, we already said, the minimization of this is nothing but the C price times quantity of nurses plus price of doctors times quantity of doctor, given a level of output, given a fixed output, that is Q0 let it be at a level Q0. We can follow a Lagrangian since the optimization function if it is not linear. Okay. In that case, sometimes C comes with some of the equations, such as I am just writing here, C might be presented as 100 plus okay, so maybe 2 times C1, okay, or x1 maybe or 3 times x2 square, or maybe anything like this equation is given, and this seems to be a nonlinear equation. Okay. And nonlinear, if your objective function is nonlinear with a constant function, constant linear function, but not unconstant linear function. We are actually referring to a constant linear function, that is our production function assumes a level. So, in that case, but here we have taken what? We have taken, but for your simplicity we have taken a linear cost function, and then an objective function in nonlinear. So, in that case one has to be linear and there has to be nonlinear. In that way we can able to optimize the point and find out through a Lagrangian multiplier function. Okay. So, but here what we did it as per the Lagrangian formula, we followed first our linear objective function. In this case, for simplicity we have taken the linear one, because our target is to minimize the cost. Plus the Lagrangian multiplier has to be given, and this is nothing but equating to the production function, and we need to actually fulfill this L by Lagrangian dl by dq with respect to n, with respect to d, and with respect to lambda. Okay, all has to be equated at 0, and we can find out and solve it and find out the solution, and this will precisely give you the optimization function we just mentioned here. Okay. And you can try with the right example, and these are available in microeconomics books also. If in the previous problem production function follows Cobb-Douglas one, if your production function is this, okay, Cobb-Douglas, find the equilibrium condition of cost minimization. So, this is what we have just mentioned. This function, if it is Cobb-Douglas one, then you can apply, like your constant function is given with this a Cobb-Douglas production function, then with the same approach by Lagrangian multiplier. Okay, so start with the cost function, then lambda times if you follow the Lagrangian multiplier formula, you will find out. So, what are the factors affecting the cost of hospital services mentioned by Ferner and Michel in 1992? Estimated multi-product cost function for 179 short-term general care hospitals in Florida from the year 1984 to 86. They found more output, it requires more cost, inpatient admission, outpatient visits, then emergency room visits, surgery minutes, etc. have positive effect on cost. Similarly, other factors you can just read what are the findings. I am not going by the points. They also included about the effect of competition. I think those will be useful for you to read and understand. So, to follow it very correctly, those are novice readers, and just to start reading microeconomics and health economics in particular, you have to read these carefully. In the next lecture, we will discuss about profit maximization model in healthcare market. With this, I think I must stop here. Thank you.